Hi everyone, welcome back. Let's see the dynamic methods to predict the bus times of a particular process. Guys, in the previous video, we have seen what are the various kind of static methods in order to predict the bus times of a process. Those are, one is process size, another one is process time. Anyhow, these two might not be the efficient ones in order to predict the bus times. So we are moving with the dynamic methods. So there are two dynamic methods are there. One will be simple averaging. Another one will be exponential averaging. Right? So in general, if you take a process, something like process P1, for this process P1, there might be some actual burst time, and in the next execution of another system, can we able to predict the burst time for this? Yes, that might be possible, right? Based on certain kind of calculations. So what I am trying to convey to you is, for example, let's say there will be a set of processes, a set of PA process, something like P1, P2 and so on, Pn, and Ti will be the burst times of these processes, which means T1 is a burst time for P1 and so on. Tn is the burst times of process Pn, right? So if you want to calculate, the Pn plus 1 burst time, you can able to go through either simple averaging technique or you can do with respect to exponential averaging technique. Exponential averaging technique is the best one because we are applying here some kind of smoothing factor. What is that smoothing factor? I will let you know meanwhile. Right? So in simple averaging, what we are going to do now? We are going to simply take the average burst times of all n processes, something like T1 plus T2 and so on, Tn. Then I can say this is the predicted burst time. Tn plus 1 is the predicted burst time. So which I can say it as 1 by n into summation of I equal to 1 to n Ti for Pi process. Okay, fine. So coming to the second one, exponential averaging. Here we are going to calculate the next burst time, that is tau n plus 1 equal to alpha into Tn plus 1 minus alpha into tau n. What is this Tn? Actual burst time of process Pn. Tau n is what? Predicted burst time of process Pn, and alpha is ranging between 0 and 1, guys. So this is what we call it as smoothing factor. To reduce the erroneous between the actual burst time and the predicted burst time, they come up with the alpha value. So based on this alpha value, this particular formula is going to vary. For example, if I want to calculate the predicted burst time of T3, then what you can do? You can just simply in this formula alpha into T2 plus 1 minus alpha into tau 2, right? So to solve this one, you have to calculate the tau 2 equal to alpha into T1 plus 1 minus alpha into tau 1. This is where your problem is going to simplify. Might be the reason is the actual burst time will be given for you and the predicted burst time is also given for you. Then we'll solve here, that will be substituted here. Then we'll get this one. So like that you can able to calculate the predicted burst times for any kind of process, right? So if you are going to place alpha value as 0, your logic might be very simple again, right? If you think that alpha equal to 0, then tau n plus 1 is equal to tau n. If you say that alpha equal to 1, tau n plus 1 equal to Tn, right? Means the earlier process actual time. If we say alpha equal to half, which I can say that it is 0.5, then you can say Tn plus 1 equal to half Tn plus half tau n, which I can write as half into Tn plus tau n. Like that you can able to note down it. So in the gate, majorly they are going to concentrate on how you are going to solve this particular problem, right? That particular problems I will take in the next video, and you can able to understand it effectively with the help of the explanation. Hope you understood this video clearly.